We'll start in 1 minute. Well, we'll continue learning how to solve quadratic equations. Last time we used the square root method, and I showed you one example of solving a quadratic equation by completing the square, but today we'll do a bunch more. Okay, so solving a quadratic equation by completing the square involves some preliminary work. Once that work is complete, the equation can be solved by using the square root property. The expression completing the square in this context simply means to create a perfect square trinomial. And you'll recall that a perfect square trinomial is what results when you square a binomial. So here are two examples. You've seen examples before, but this is just a reminder. If you square the binomial x minus 3, that means x minus 3 times x minus 3. And when you multiply it out and combine the like terms, you get x squared minus 6x plus 9, which is a perfect square trinomial. Another example, 4y plus 5 squared means 4y plus 5 times 4y plus 5. Multiply that out and combine like terms, the result is a perfect square trinomial. Okay, so since a perfect square trinomial has characteristics that are known, under appropriate conditions, a perfect square trinomial can be constructed. The following example illustrates what to do when completing the square. So in this example, we're beginning with x to the second plus 6x. Notice that the coefficient of x squared is 1. That's the condition that we want before completing the square. Once the coefficient of x squared is 1, we compute 1/2 of the coefficient of x. The coefficient of x is 6, and so 1/2 times 6 is 3. Then we square the number that we found in step 2. We found that 1/2 of 6 equals 3, so in this step, we square that number, 3 to the second equals 9. And when we add the number 9 to x squared plus 6x, we get x squared plus 6x plus 9, and that is a perfect square trinomial. Once again, we call it a perfect square trinomial because it's the result of squaring a binomial. Okay, we'll look at some quadratic expressions that have just two terms. And all we're going to do in this, for these 6 examples, is complete the square or create perfect square trinomials. So with x squared plus 2x, notice that the coefficient of x squared is 1. So I'll write that the coefficient of x squared is 1. So we proceed to the second step. Once the coefficient of x squared is 1, compute 1/2 of the coefficient of x. So 1/2 times 2 is 1. Once we have 1/2 the coefficient of x, we square 1. So if we add this number to x squared plus 2x, we have a perfect square trinomial. So that means that it can be written as a binomial squared. So what binomial do we square to get x squared plus 2x plus 1?
Just x plus 1.
Yeah, x plus 1 is the binomial. Hey, and this is a really simple example, but I'll show you what works in general. Once the coefficient of x squared is 1, you take half of the coefficient of x. 1/2 of 2 is 1. Then you square that number. 1 squared is 1, and then add it to x squared plus 2x. To know what binomial you have to square, well, since the first term is x squared, the first term in the binomial is x. And then what follows x is what you get when you take 1/2 of the coefficient of x. So 1/2 of 2 is positive 1, so you put plus 1. Okay, that is going to work in general. For the next one, here we have x to the second minus 2x. The coefficient of x squared is 1. So then we proceed to find 1/2 of the coefficient of x. 1/2 times negative 2 is negative 1. And then we square that number. The number negative 1 squared is positive 1. And so we add positive 1 to x squared minus 2x. This is now a perfect square trinomial. That means it's equal to a binomial squared. So what binomial is it? Well, inside the parentheses, we have to put a binomial. Since the perfect square trinomial has 1x squared, the binomial has x. And then 1/2 of negative 2 is negative 1. So that indicates that inside the binomial, we put minus 1. So x minus 1 squared is equal to x squared minus 2x plus 1. Okay, the next example is a little more involved, slightly more involved. Here we have x to the second plus 7x. First note, the coefficient of x squared is 1. So we can proceed to create a perfect square trinomial. So I'll give you a few seconds, and if you haven't answered a question in a while, you get first shot at it. So what do we do in order to create a perfect square trinomial? You can type an answer in online if you're watching. So anybody on YouTube know how to create a perfect square trinomial out of this? X squared plus 7x. Well, the first part, x squared, the coefficient of x squared is 1, so we proceed to the second step. The coefficient of x is 7, so we compute 1/2 of 7. 1/2 times 7 is 7/2. Then we square that number. When we square 7/2, that means 7/2 times 7/2, which is 49/4. So 49/4 is the number that we add to x squared plus 7x. So x squared plus 7x plus 49/4 is a perfect square trinomial. So that means it's equal to some binomial squared. So to determine what binomial we square to get x squared plus 7x plus 49/4, well, you can just factor it using methods of factoring. But since we created a perfect square trinomial, we can use a different method to find the binomial. Since the first term is x squared in the trinomial, the first term in the binomial is x. And then what do we determine, or how do we determine what follows x? Well, what follows x for the binomial is the same number that we got when we took 1/2 of 7. We took 1/2 of 7 and got positive 7/2. So that means over here in the binomial, we have x plus 7/2. You can always verify by multiplying that you have the correct binomial squared. So why don't we do that? If you're ever in doubt, you can always check your work. So verify. So we multiply x plus 7/2 times x plus 7/2. So x times x is x squared, and then plus x times 7/2 is plus 7/2 x. And then plus 7/2 times x again. And then plus 7/2 times 7/2, which is 49/4. The two middle terms are like terms. So we get 7/2 x plus 7/2 x is 14/2 x. 14/2 x simplifies to 7x, and then plus 49/4. Okay, the next one. X squared minus 13x. The coefficient of x squared is 1. So we proceed to the second step. We take 1/2 of the coefficient of x. So 1/2 of negative 13 is negative 13/2. Then we square that number. When we square negative 13/2, we get positive 169/4. So we add this number to x squared minus 13x. And we now have a perfect square trinomial. So you need to know how to factor the perfect square trinomial. So we follow the same procedure that we've been following so far. The first term in the perfect square trinomial is x squared. So the binomial has a first term of x. And what follows x in the parentheses, this is what follows x inside the set of parentheses is the same number we got when we took 1/2 of negative 13, which is negative 13 halves. So that means in the binomial, we subtract 13 halves. So x minus 13 halves quantity squared is equal to the perfect square trinomial. Okay, the next one, we just have a couple more practice problems. The coefficient of x squared is 1. So we take 1/2 of the coefficient of x. 1/2 of 10 is 5. Then we square that number. 5 squared is 25. And so this is the number that we add to x squared plus 10x to create a perfect square trinomial. So x squared plus 10x plus 25 is the perfect square trinomial. That means it's equal to a binomial squared. The first term in the binomial is x, which is the square root of x squared. And then the number that follows x inside the parentheses is the same number that we got when we took 1/2 of 10. We got positive 5, so we write x plus 5 quantity squared. Okay, one more. X squared minus 24x. The coefficient of x squared is 1. So we take 1/2 of the coefficient of x. 1/2 of negative 24 is negative 12. Then we square negative 12, and we get positive 144. This is the number that we add to x squared minus 24x to get our perfect square trinomial. So what binomial do we square to get x squared minus 24x plus 144? Well, the binomial has to have x because the first term in the trinomial is x squared. And the number that follows x inside the parentheses is the same number that we got when we took 1/2 of negative 24. That number is negative 12, so inside the parentheses we have x minus 12. And then if you want, you can verify by multiplying that you have the correct binomial squared. Okay, so that gives us a good foundation for proceeding to the next set of examples where we solve the equations by completing the square. Okay, here we have x squared plus 10x minus 9 equals 0. If we're going to solve this by completing the square, step 1 is to get the x squared term and the x term by itself on one side of the equation and move the constant to the other side. So in this one, the first step is to add 9 to both sides. So we get x squared plus 10x equals 9. The next step is to divide every term on both sides of the equation by the coefficient of x squared. So in general, that's what we want to do. Divide both sides by the coefficient of x squared. When the coefficient of x squared is 1, dividing by 1 doesn't change anything. But there will be situations where the coefficient of the squared term won't be 1. So I'm going to always mention that step just so that you'll have additional reminders that you need to, in general, divide every term on both sides by the coefficient of the variable squared. Okay, so divide everything by 1, nothing changes. The next step is the completing the square step. Now we're going to add a number to both sides of the equation so that the left-hand side is a perfect square trinomial. Well, that's what we were practicing earlier. What would I have to add to x squared plus 10x to get a perfect square trinomial? Well, we take 1/2 of the coefficient of x, 1/2 of 10 is 5, and then 5 squared is 25. And so the number that we add to both sides of the equation is 25. So we're solving an equation, so whatever you do to one side of the equation, you have to do to the other side. The left-hand side of this equation is a perfect square trinomial. That means we can write that as a binomial squared. In this case, it's the binomial x plus 5 squared. On the right-hand side, 9 plus 25 is 34. And now we apply the square root property, which is what we talked about on Friday. So now apply the square root property. Okay, we have x plus 5 quantity squared equals 34. When we apply the square root property, we write x plus 5 equals positive and negative square root of 34. The square root of 34 cannot be simplified, so we can write the two solutions. We subtract 5 from both sides, so x equals negative 5 plus and minus the square root of 34. If you want to write the solution separately, you can. One solution is x equals negative 5 minus the square root of 34. The other solution is x equals negative 5 plus the square root of 34. This is not as complicated as it can get, but it's still a good example that illustrates the general method for solving a quadratic equation by completing the square. Every quadratic equation can be solved by this method, completing the square. Okay, the next one, y to the second minus 8y minus 22 equals 0. The first two steps are interchangeable, but usually what I do is I move the constant so that it's on the opposite side of the equation as the squared, the variable squared and the variable term. So the first step here is to add 22 to both sides. So we get y to the second minus 8y equals positive 22. Then get into the habit of thinking to divide every term on both sides by the coefficient of y squared. Even though the coefficient of y squared is 1, just get into the habit of thinking through that step. When we divide every term on both sides by 1, nothing changes. So the next step is completing the square step. In the next step, we're going to add a number to both sides of the equation so that the left-hand side is a perfect square trinomial. Okay, the coefficient of y is -8, so we take 1/2 of -8, which is -4. And when we square -4, we get +16. Okay, so we add 16 to both sides. Y squared minus 8y plus 16 equals 22 plus 16. And y squared minus 8y plus 16 is a perfect square trinomial. So we write it as a binomial squared, which is y minus 4 squared. And 22 plus 16 is 38. And now we apply the square root property. We have y minus 4 squared equals 38. So we can write y minus 4 equals positive and negative square root of 38. Then we add 4 to both sides. And the two solutions are y equals 4 plus and minus the square root of 38. The square root of 38 cannot be simplified any further. So this represents the two solutions. Okay, I'll give you a couple of minutes to work on the next one. We're starting out with -3x squared plus 36x equals 33. So go through the steps that I've described. Okay, let's go through this. The constant is already on one side. We want the x squared term and the x term on one side and the constant on the other. So we already have that. Then the next step, so somebody type in what the next step is. So I have more people signed in than are watching. I can tell how many people are watching. So, dang. Was that? Oh. Okay, the next step is divide every term on both sides by -3. Divide every term on both sides by -3. So when we do that, we get x squared minus 12x equals -11. And now that the coefficient of x squared is 1, we create a perfect square trinomial. So we take 1/2 of -12, 1/2 of -12 is -6, and then we square that number. -6 squared is +36, and then we add 36 to both sides of this equation. And we get x squared minus 12x plus 36 equals -11 plus 36. X squared minus 12x plus 36 is a perfect square trinomial. So we write it as a binomial squared. It's x minus 6 squared. And then the right-hand side, -11 plus 36 is 25. Now we apply the square root property. We have the binomial x minus 6 squared equals 25. When we apply the square root property, we get x minus 6 equals positive and negative square root of 25. So in the next step, I'll do two things at once. I'll add 6 to both sides and also simplify the square root of 25. So we have x equals 6 plus and minus 5. We can simplify further, so we should do that. One solution is x equals 6 minus 5, or +1. And the other solution is x equals 6 plus 5, or 11. So x equals 1 and x equals 11 are the solutions. When you have solutions to a quadratic equation that are integers, do you know what that means? When the solutions are integers, that means that we could have solved by factoring, because we could factor it using integer coefficients if the solutions turn out to be integers. But you can always solve an equation using completing the square method. Okay, the next one, y to the second minus 5y minus 3 equals 0. In this case, we want the y squared term and the y term on one side of the equation and the constant on the other side. So here we start by adding 3 to both sides. So we get y squared minus 5y equals 3. Then divide every term on both sides of the equation by the coefficient of y squared. The coefficient of y squared is 1, so when you divide every term by 1, nothing changes. So we can proceed to the completing the square step, or the creating a perfect square trinomial on the left-hand side of the equation step. So now we take 1/2 of -5 Negative 5 is the coefficient of y. 1/2 of negative 5 is negative 5 halves. And then we square that number. The number negative 5 halves squared is positive 25 fourths. And this is the number that we're going to add to both sides of this equation. So we get y squared minus 5y plus 25 fourths on the left-hand side, and on the right-hand side, 3 plus 25 fourths. So 3 plus 25 fourths, convert 3 to the fraction 12 fourths, and then 12 fourths plus 25 fourths is 37 fourths. Y squared minus 5y plus 25 fourths is a perfect square trinomial. That means it's equal to some binomial squared. So the binomial has to have the variable y, and then the number that follows y is the same number we got when we took 1/2 of negative 5. So 1/2 of negative 5 is negative 5 halves, so that means inside this set of parentheses we write y minus 5 halves. And this equals 37 fourths. Now we apply the square root property, and we get y minus 5 halves equals positive and negative square root of 37 fourths. So the square root of 37 fourths is the square root of 37 over the square root of 4. And so the denominator simplifies to 2 because the square root of 4 is 2. So in the next step, we'll add 5 halves to both sides. And we'll also simplify the square root of 37 fourths. I guess we can do it in a couple of steps. The square root of 37 fourths is the square root of 37 over the square root of 4. But we simplify the square root of 4. So if we write the solutions separately, one solution can be written y equals 5 minus the square root of 37 all over 2. And the other solution, y equals 5 plus the square root of 37 all over 2. Be careful with the division bars. If you don't divide the entire quantity, but only a portion of that quantity by 2, then you will have written down an incorrect answer. Oh, another thing, when writing square roots of numbers, make sure that you put the entire number inside the square root so that there's no ambiguity about what you've written. Okay, the next page. Oh, this is sort of at the next level, but not that much more difficult. So this is a really good method for solving quadratic equations. You can always use the completing the square method to solve a quadratic equation. Okay, so on this one, we can start by adding 50 to both sides because we want the x squared term and the x term on one side of the equation. So start by adding 50 to both sides. Then divide every term on both sides by the coefficient of x squared. So in this one, we divide every term on both sides by 5. And we get x squared plus 3x equals 10. Now that the coefficient of x squared is 1, we are going to add a number to both sides of the equation so that the left-hand side is a perfect square trinomial. Okay, so when the coefficient of x squared is 1, we take 1/2 of the coefficient of x. 1/2 of 3 is 3/2. Then we square that number. 3/2 squared is 9/4. So we're going to add 9/4 to both sides of that equation. And we get x squared plus 3x plus 9/4 equals 10 plus 9/4. And we have to simplify the 10 plus 9/4. And we also have to write a binomial squared that's equal to this perfect square trinomial. Okay, so we have some binomial squared, and the least common denominator on the right-hand side is 4. So 10 over 1 is equivalent to 40 over 4. So what binomial do we square?
X plus 3 over 2.
Yeah, x plus 3 over 2. So we know we need an x because the perfect square trinomial has x squared. And then the number that follows is the same number we got when we took 1/2 of 3, which is positive 3/2. So we write x plus 3/2. And 40 over 4 plus 9 over 4 is 49/4. Okay, now we apply the square root property. X plus 3/2 equals positive and negative square root of 49/4. In the next step, we'll subtract 3/2 from both sides and also simplify the square root of 49/4, which is 7/2. And we can simplify further. One solution is negative 3/2 minus 7/2, or negative 10/2, or negative 5. And the other solution is x equals negative 3/2 plus 7/2, which is 4/2, or 2. So just to summarize, x equals negative 5 and x equals 2 are the solutions. Well, you'll probably have a test question, possibly even a quiz question, that call for solving an equation by completing the square. So if those are the directions, then just go through the completing the square process. On the other hand, if the directions simply say solve the quadratic equation, then you can solve it using any method you want. So another method to solve this one that you know about, we can divide every term on both sides by 5 first. So divide both sides by 5. And a motivation for doing that is the fact that every coefficient is a multiple of 5, and 0 divided by 5 is still 0. So if you divide everything on both sides by 5 first, we get x squared plus 3x minus 10 equals 0. And this can pretty easily be solved by factoring, which is a method that we've already learned. The two factors are x plus 5, and x minus 2. So the two solutions are negative 5 and 2. Okay, solve the next equation by completing the square. 2y squared minus 10y minus 32 equals 0. So step 1, add 32 to both sides. So we get 2y to the second minus 10y equals 32. Then divide every term on both sides by 2. We get y squared minus 5y equals 16. Then we add a number to both sides so that the left-hand side is a perfect square trinomial. So y squared minus 5y plus a number equals 16 plus a number. So we take 1/2 of negative 5, which is negative 5/2. And when we square negative 5/2, we get 25/4. So we add 25/4 to both sides. And the left-hand side is now a perfect square trinomial. It's y minus 5/2 squared. And the right-hand side, 16 plus 25/4. 16 is equivalent to 64 over 4. And 64 over 4 plus 25 over 4 is 89 over 4. Then we apply the square root property. We get y minus 5/2 equals positive and negative square root of 89/4, but I'm just going to write it as the square root of 89 over 2 because the square root of 4 is 2. And so our solutions are, when we add 5/2 to both sides, y equals 5/2 plus and minus the square root of 89 over 2. Okay, so I did that one fairly rapidly. If you need to show more steps, then go ahead and show more work. Okay, the next problem, negative 4x squared minus 20x equals negative 4. On this one, we already have the x squared term and the x term on one side and the constant on the other. So the first step in this one, divide every term on both sides by negative 4. And when we divide every term on both sides by negative 4, we get x squared plus 5x equals positive 1. Okay, then we take 1/2 of the coefficient of x. 1/2 of 5 is 5/2. And then we square 5/2 to get 25/4. So we add 25/4 to both sides, x squared plus 5x plus 25/4 equals 1 plus 25/4. This is the same as 4 over 4 plus 25 over 4, or 29/4. Then x squared plus 5x plus 25/4 is x plus 5/2 squared equals 29/4. Then apply the square root property. We get x plus 5/2 equals positive and negative square root of 29/4. And then x equals negative 5/2 plus and minus. We simplify the square root of 29/4, so we have the square root of 29 in the numerator and 2 in the denominator. Okay, the last problem, we have a little over a minute to finish this one. So add 8 to both sides to start with. 2y to the second minus 14y equals 8. Then divide every term on both sides by 2. We get y squared minus 7y equals 4. Then we complete the square. We take 1/2 of negative 7. So 1/2 of negative 7 is negative 7/2. Then we square negative 7/2 to get 49/4. And then we add 49/4 to both sides. So I'm going to replace 4 with 16/4 because we're adding that to a fraction with a denominator of 4. And then we have the binomial y minus 7/2 squared equals 65/4. Then apply the square root property, y minus 7/2 equals positive and negative square root of 65/4. And then the last step, add 7/2 to both sides, y equals 7/2 plus and minus the square root of 65/2. Okay, so we're out of time. Tomorrow we'll move on to the next section, 9.3.